2.6 Video streaming and CDNs. Video streaming, the term is very simple. Okay, YouTube, Netflix, Hulu, and Kankan. They're all video streaming services. So what they do is essentially stream videos to you. Now, what is less heard of is this term, CDNs, Content Distribution Networks. You probably heard me talking about these networks a little bit when I was talking about the internet structure. Right? So there's backbone of the internet, there's ISP, and there's end users. But there's also these global service providers. Content distribution network is one of these global service providers, such as Google. Right? So one of the oldest CDN company is called the Akamai. Nowadays, we do have these cloud service providers, Azure, AWS, okay, also in the market for competition to provide content distribution network services. So in a way, the video streaming services such as YouTube is actually the subscriber of the CDN services. So video streaming services high up, very close to the user, and indirect interaction with the user. The CDN is one, half layer below, although still in the application layer, but half layer below, right underneath the video streaming services. Now, in order to explain why video streaming services these days uses CDNs, I'll have to share first how hard it is to provide video streaming services. Let's look at the video traffic coming out of major services such as Netflix and YouTube. So this is according to US residential ISPs statistics. 70% of the traffic coming downlink to the household from Netflix. 60% from YouTube. So just these two video services together is already more than 50% of the downlink traffic. So you see, video, a major consumer of the internet bandwidth. And this is mainly because of the number of users we have on each of these video services and the demand. Okay, so the number is still growing, demand is also rising. So we see challenges ahead. And the first major challenge is the scale. So that is related to the demand. As the number of users increase and as the number of video demands increase. So when we have users at that scale, can you imagine serving all the videos using just one single server? If you recall, when we were talking about the hierarchy in DNS, the domain name system, we are only serving host to IP mapping. That is actually very, very short messages. But now we're serving videos. Even serving short messages like what DNS is doing, we need a distributed system. So you can imagine that a single mega video is not going to work. The second issue is also this. Hey, because we have so many users, and these users could be like Polly sitting right here using a desktop and connected to the wired network. But it could be, some of you guys out there, still taking the metro. You might be connected to the internet using 4G and you are moving around. So the connectivity and the internet access, you can imagine, me and a metro commuter will be very different. You cannot be sending a high-quality video stream to such a user on metro and moving around. But hey, I can actually take high-quality video, but send me a low-quality video. Neither of us will be happy. All right, so we do have this other challenge here, heterogeneity. Different users will actually demand different qualities because we have different capabilities. Some of us are stationary, some of us are mobile. Some of us has a lot of bandwidth to download videos, but some of us don't. Right? So to address the demand, to address the heterogeneity, okay, in these users, solution is to use CDN, which is a distributed application level infrastructure. We'll definitely talk about CDN more later. Now let's talk about the video a little bit more. This is the content we're distributing there. Okay. Originally, it was an analog signal. It's a sequence of images that we are displaying. Okay, and the display is at a constant rate. That means at every time unit, you take a snapshot of what it looks like right now. Okay, so therefore, at a constant rate, a sequences of these images. So, for example, we take 24 images per second. So that is what the cameras are doing, taking images continuously. Right? So Poly right now is sending 30 images per second, or sometimes it's also called 30 frames per second. Your display, okay, will be displaying 30 images per second as well. Now, 30 images per second is actually pretty low. Therefore, from time to time, you see Poly's action is a little bit, awkward, not exactly smooth. These days, in order to make sure that you have very, very smooth motion, 60 frames per second is the way to go. Right? But hey, sending 60 images per second versus 30 images per second, that is at least, okay, twice the amount of traffic. So you see a little bit of trade-off there. If we want very high video quality, that also usually imply higher bandwidth requirement. And the digitalization process is this. So every second we take a certain number of images, and within each image, we divide the image into discrete number of these pixels. So you see each of these red dots is a pixel. Okay? And for each pixel, we use a limited number of bits to represent the color. Okay? So usually the intensity of the red color, intensity of the blue component, intensity of the green component. Now, because the number of bits is limited, so that you actually approximate, okay, the actual intensity to some quantile. So this is also called the quantization process, digitalization or quantization process. Now, coding. So provided all these bits being generated, the next thing we do is to just simply send it. Okay, how about that? Well, that was actually what we were doing maybe a couple decades ago. Okay, but nowadays we add compression mechanisms or coding mechanisms. All right. So compression, coding. Compression is more specific, meant that we would reduce the number of bits we need to transmit, reduce the number of bits we need to store for the same content. But coding usually is more general, okay, not necessarily reducing the size, sometimes increasing the size for the purpose of trying to recover from errors. Okay, so coding is a little bit more general. It's just that when we're talking about coding videos, it's usually just compressing videos. And we're exploiting, okay, redundancy that is natural in the content. So redundancy could exist here. Okay, within one frame, within one image, you see here the sky. All these pixels in the sky, they would actually look very much the same. The colors are pretty much the same, right? So that is called a spatial coding. Okay, so instead of sending all the values one by one, okay, how about sending only two values? The color and the number of times the pixel, the color is going to repeat. Okay. So two numbers instead of n numbers. That reduces the number of bits we need to transmit. Okay. The other way, so that was spatial. The other way is temporal. So that is to look at this from one frame to another frame when we're in action. Okay. For most cases, slow action, you will see that frame I and the next one, I plus 1, there's not going to be much difference. So, hey, these pixels remain similar here. The colors pretty much stay the same, right? So why don't we, instead of sending all the pixels in a frame, okay, send only the differences from the new frame to the old frame, right? So if we take a subtraction, okay, newer frame subtracting the older frame, then you get, very little differences. Most of the pixel differences are probably just 0. Then it's much easier to send a whole bunch of zeros, which you could use just 0 and the number of times the 0 repeated itself. Okay, so a combination of spatial and temporal redundancy exploitations. In the coding schemes, the really old one, those that are decades ago, are the constant bit rate coding. Because what? The number of bits is fixed to represent each pixel, and the number of pixels is fixed per image, and the number of images you take per second is also fixed. Therefore, the number of bits you're sending out is also fixed. Nowadays, the coding is variable bit rate. So it really depends on the amount of spatial and temporal redundancy you can exploit. Those movies with really fast actions, then you don't get very good compression rate because the diff from frame I and frame I plus 1 usually large. So you don't get to save too much. As a result, the bit stream you send out is in different bit rate. Okay, so lots of actions, high bit rate. Not much motion, low bit rate. So, examples. This is MPEG version 1, MPEG version 2, MPEG version 4. And you see in the older version, the encoding rate is much higher. Okay. Nowadays, using MPEG 4, the suffix of the file names of MPEG 4 video is usually just this, MP4, something.mp4. Compression rate is really good, so we could send very high quality video under 1 megabits per second. Now, yeah, you see version 2 seems to be requiring more bandwidth. That's because it's in DVD quality. The number of pixels that you're sampling is way higher. Okay, so CD-ROM is actually pretty old, as I said, a decade ago, and maybe a couple decades ago.